Okay, I'll get you started on this one. Here's a graph of y equals 6e to the negative 0.2x, which I wrote as negative 1/5 x. This red graph right here. Here's the graph of y equals the square root of x, which I wrote as x to the 1/2. And we're trying to examine the region between x equals 1 and x equals 4 and revolve this gray region about the x-axis. So it looks to me like the washer method is what we're going to want to use. So our typical cylinder is going to be perpendicular to the axis of revolution. And then we're going to use outer radius squared minus inner radius squared, or pi times the definite integral from 1 to 4 of, there's the outer radius, that's the distance from the axis of revolution up to here, and for every x coordinate between 1 and 4, that height is what I get when I put x in right here. So the outer radius squared minus the inner radius would be this distance right here from 0 to the graph of x to the 1/2. So there's the inner radius squared. When I simplify these two terms that are being squared, I get 36e to the minus 2/5 x minus x dx. And I separated these into two separate integrals, moving this constant out front. There's a 36 pi definite interval from 1 to 4 of e to the negative 2/5 x dx. And there's the second integral, minus pi times the definite interval from 1 to 4 of x dx. Now, why did I separate it? Because I can see that to find the antiderivative of e to the minus 2/5 x, I'll probably want to use u substitution. So all this stuff in red here is what I would do to evaluate that definite integral. This one should be pretty straightforward. The antiderivative of x is 1/2 x squared. 1 to 4, pretty straightforward. But over here, when x is 1, u is negative 2/5, so we'll have a negative 2/5 here. We'll have a negative 8/5 up here. And out front, we'll have a negative 90 pi. So we might want to interchange the limits of integration, in which we'll take the opposite of the negative 90 pi, give us 90 pi. So I'm going to leave that to you. I'm going to leave the rest to you, but I'm going to post a link to a Desmos graph that shows the solution, and you can take a look at that if you want. So there you go. Hope that helped, and if you have any questions, post a comment.